Hey, I'm going to walk through a little notebook that I did here this afternoon, uh, exploring some climate model output, which I've never done before. So it's kind of fun. Um, yes, I'm just going to walk through this notebook. So um, we're importing intake. A lot of the model output is in an intake catalog, which is a Python specific catalog that makes data loading pretty easy into X-Ray. A plotting package, and then we're just using pandas to create a time coordinate because the time coordinates were kind of goofed up in this particular model I was looking at. So um, yeah, so we need to run that cell, shift enter. So we're importing these packages. Oh, and by the way, we're running this on this Jupyter Pangeo Jupyter Hub on Google Cloud, and the data is actually on Google Cloud. So we're opening up this intake catalog, and we can list what's in the catalog. There are these two data sets: the CESM POP high res control and a CESM POP high res RCP 8.5. And this is a 10-kilometer grid, so I thought it would just be interesting to look at a higher resolution model. If we can take a look at like uh, what's in what this data set actually is. If we just look at the if we look at the key for that particular data set in the catalog, we can see it's got a bunch of options here, but there's a little description. We can see that the data is actually sitting on Google Cloud Storage. And actually, and importantly, we can see down here what the time period is from 2000 to 2050. So the nice thing about these, when it's in an intake catalog, you can just do the catalog, and you can say to Dask, and you've got it as an X-array data set. So we can insert a cell here if we want to just take a look at what this thing looks like. We can just type DS0, and it'll spit back all the data variables. We can see we have sea surface temperature, sea surface salinity, and some and those are. So these are all 2D variables from this particular data set. But I just want to kind of show how this whole thing works. And we can explore other data sets later. So probably could have done this fancier way, but I just repeated the exact same thing and I'm going to call it DS1. So now we have DS0 is the control, DS1 is the RCP 8.5. And then we could look at we could look at one particular variable by, let's just go like DS1 dot, and then we can do tab. Actually, tab is not too interesting. If we type the first letter of something and we type tab, we can see the different variables. So sea surface height and sea surface temperature. If we, sea surface, if we go ahead and click shift enter on that, we get a little bit more information on this particular variable. Okay, so we can see this variable, 16,000 time steps, 2,400 by 3,600 in LON. It's about each chunk is about 32 megabytes, and the chunk is the entire spatial domain and one time step. So it's not going to be, this would not be a great data set to extract a time series from over the 50 years, but it is a good data set for, it's just a fine data set for extracting surface fields or for calculating values over over some period of time, like loading lots of chunks of data. So I'm going to visualize this with HV plot, and it likes longitude to be between minus 180 and 180, which this isn't. So this little line here is going to assign some coordinates to basically just convert to a minus 180 to 180, and then it also doesn't have any 1D coordinates. Like usually there'd be some projected coordinate X and Y, but there wasn't. So I just created some dummy index coordinates and longitude and latitude, and their values are just the range of from just the integers from 0 to the max value. So let's go ahead and do that, and then basically the time values were sort of nonsensical. So I just did days since 2000 here, and used pandas to create a 1 day long record, because these are daily values. So yeah, so I can just go ahead and create those different data arrays and then assign those to the coordinates. And so now if we look at one of these, the data set, we see these additional coordinates here if we open this up. These are the data variables, and these are all the coordinates. If we open these up, we should see this nlat and nlog that I defined, and they're just, yeah, just like I said, they're just integers. And the reason for doing that is that then we can select on those integers for the whole data set if we wanted to explore different variables. And so, this was sort of trial and error to figure out where the Adriatic or where the Mediterranean was, but I just made a plot and then changed the indices until I got the Med, and so it's so index is 950 to 1600 in longitude and 1500 to 1750 in latitude. But this is just a nicer little way to slice. So and we're not, we're just like virtually slicing here. We haven't loaded any data except for the coordinate data. So now if we look at DS0, we see it's only 250 by 650, and then, well, let's go see what this looks like. We can pick a particular day, for instance, like August 1st, 2030, and then we can select from. Again, this could probably be fancier, but I'm just extracting a data array that's that specific value. I'm selecting time equals that S time value, method equals nearest in case there's not one exactly at that time. So I do that, and then I just basically subtract these two arrays here. So I have a difference array, and so I can look at the DA1 is the RPC 8.5. So let's finally take a look at this. Probably should take a look before, but this is just HV plot quad mesh. So I'm specifying the latitude and longitude variables here as X and Y. I'm saying geo equals true because they are lat and lon. I'm putting on a tile map service, which is so you can see what the base map and make sure it's in the right place. And I'm saying rasterize equals true, so it rasterizes on the back end and then just delivers the data values back here. So you can see, this is kind of, there's a few weird values in here that are causing these lines. I'm not sure how to get rid of those yet, but, if we hover over, we can see what these values are. So we can see that, we've got 27.2 here, and if we zoom over here, we can see the potential temperature is 17.8. We can turn this thing off by clicking on that hover tool, and then so that little blue line goes off, and we could click this pan button off if we wanted to, and then click on this zoom tool, and then we could zoom into the Adriatic here, and when I rezoom in, it'll redraw to the resolution of the to the resolution of the data, and also rescale the color map to give us the full dynamic range. So this is kind of cool. So we can if it was more highly resolved data, we could see the full resolution of the data without overwhelming the browser. So this is kind of cool. We can go interactively explore here. We can turn this hover tool back on, and see what these values are. So we can see that's 21 degrees. And so on. So let's take a look at the difference. So now we've got this difference field. So we're going to take a look, see how much the Med is predicted to warm under this RPC 8.5 scenario in the year 20, sometime in 2030. So this is the difference in the temperature fields, right? So this will be the increase in temperature. So you can see some regions increase, and some regions are actually predicted to decrease from this model. I don't know how accurate this model is. But anyway, you get the idea of the power of the tool. Okay, so that was just visualizing single chunks. But now we're going to spin up this cluster. And this is, there's no real advantage to having a cluster when you're just visualizing single time steps, because each time step from a variable is just one chunk of data, right? So read the chunk, visualize it. It's certainly nice to have this data set that's very, manageable, to just extract the data from without downloading anything. But now we're saying give us a gateway cluster, a cluster of that's working on Kubernetes with 10 workers, and we can take a look at the cluster and see if we actually cluster. I guess we want to do client, and we can see cluster info here. Okay, there's our cluster. Let's actually open up this little visualization tool here to see what the cluster is doing. We can drag this dashboard into the little window here, and if we hit return here and close that back down. We have a little cluster map here which will show us these workers as they come on board, and then whatever work they have to do will show up in this little progress bar here. So all right, so now we're going to actually do some calculation that takes some significant computation. We're going to take all the daily values for a year, so 365, and we're going to count each field where we're going to count the values where it's greater than a certain critical value. So I just specified like 23 here and picked a particular year. So here we select all the data for the SST variable that's in that year. Okay, so again, we can just, it's a nice sort of selection here. We can just specify the actual coordinate values here. We don't have to use indices. And then this next line is basically saying, okay, so you take this array that is all the values for the year, and we're just going to find all the values that are greater than this t-crit. And then we're just going to sum them up over the dimension of time. And this dot compute on the end says, okay, actually compute those values. Don't just show me the array that would result if the computation was done. That's sort of the way Dask works. It's like a delayed computation. And you need to put like a dot compute or a dot load on to actually have it do the calculation. So you can see these workers coming in the little cluster map. And if we go ahead and execute some of these, like t-crit, okay, and the year, and now we should start seeing some work being done. And there, yeah, here's the progress down here of all the different little things that need to be done to do this calculation. And they're being done by these 10 different workers. This is not a huge calculation, and it's, that's done. And so then we can go on to looking from the control to the RPC 8.5. And, same kind of thing. Each worker is doing a little chunk of work and passing some information to another worker and then back to the main scheduler. But you can see these really simple expressions are actually doing really powerful calculations on the back end. So we can take the difference now between the two and plot it up again. And now we can see the difference in the number of days, the increase in the number of days, say, over this threshold value for a particular year, for the entire year, right? So for 2030, this is the number of days. So it actually, this thing's kind of annoying, actually. Probably should turn that off by default. But again, if we, we can zoom in here and see, like in the Adriatic, there's some, it actually, I apologize for this line again, but there's some days where, there's some regions where it actually goes down and other regions where it goes up, which I think is kind of interesting. Again, I don't know how accurate this model is, but anyway, you get an idea of how easy it is really to work with Xarray and these tools with a cluster, and it's we can look at other data sets, and then of course at the end we can shut this guy down. So I'll send along this notebook, but hopefully that was useful.